Hello gems, welcome back to another video. So today we will be doing an exciting thing. We will be solving memory based BITSAT questions from session 1. Yes, the session that you answered in July this year. So first of all, a huge shout out to Harshal's YouTube channel because most of these questions came from their BITSAT analysis. Also a huge thank you to all those students who personally DM'd me some memory based questions. Yes, thanks a lot and let's begin. So starting with question 1, which is from 4th July shift 1, here you are supposed to find the ratio of energy level n is equal to 2 with that of n is equal to 4, okay, for a hydrogen atom. So basically they are asking you for the ratio of energies for the stationary state n is equal to 2 and n is equal to 4, okay. So energy, the formula for it is minus 13.6 z square divided by n square. Okay, so clearly you can see that it is for a hydrogen atom, so Z does not matter over here. Z is 1, right? Z stands for atomic number, so Z is 1 over here. So clearly you can see that energy is inversely proportional to n square. N is the number of the stationary state. Okay, so the ratio that you are supposed to compute is E2 by E4, right? Energy levels n and 4. Okay, so E2 by E4 will be simply inversely proportional to their respective n's, right? So it will be E2, for E2 we have 2 squared, and for E4 we'll have 4 square, right? So this is 16 divided by 4, so that is 4. So the ratio is 4 is to 1. Simply 4 is to 1. Option A, very simple, is the correct choice over here. Over to the next question. So question number 2 over here, again from 4th July shift 1, and again a ratio type of question. So you are supposed to find the ratio of the longest wavelength of the Lyman series to that of the Balmer series. Okay, so you are just supposed to compare, or you are just supposed to find the ratio of longest wavelength of this series to longest wavelength of that series. Okay, so it's a pretty common topic at BITSAT. You will see one of these questions being discussed in a series, and you'll see some of them being discussed in the recently discussed mock test series. Okay, so anyways, the question found its way at BITSAT, so let's solve it now. So the formula for this question that we'll use is 1 by lambda is r into 1 minus n final square minus n initial square. Okay, so here for Lyman series, okay, n final is 1. Okay, this is for Lyman series, and for Balmer n final is 2. Okay, so the maximum wavelength, the catch point over here is the maximum wavelength corresponds to the shortest transition. Okay, energy and wavelength are inversely proportional, so the maximum wavelength will be the shortest energy transition. Okay, so shortest transition will be from n initial is equal to 2 to n final is equal to 1. This is the shortest one, right? 3 to 1 will be the next one. Okay, so this is the shortest one, 2 to 1. Okay, so for Lyman series, this is the shortest transition, and it will correspond to the longest wavelength. Okay, the one that we are supposed to deal with over here. Okay, so 1 upon lambda max. Okay, this lambda is the longest wavelength for Lyman series. Okay, so I'll write L. So this will be r is a constant, 1 minus n initial square, sorry, n final square, so that is 1 square anyways, and this is n initial square. Okay, n final square minus n initial square, so this will be 2 square, which is 4. Okay, so 1 minus 1/4, that is 3/4, so 3r by 4, and that is 1 upon lambda L. Okay, so for the Lyman series, the maximum wavelength will be, just cross it, it will be 4 by 3r. Now similarly, we have to discuss it for the Balmer series. The only change over here is that n final will be 2. Okay, for a Balmer series, basically all the transition end up to 2. Okay, so n final will be 2 in this case, and n initial, again it's for the longest wavelength of the Balmer series. Now longest wavelength corresponds to shortest transition, so n initial will be 3. Okay, so from 3 it will come to 2. Next one will be 4 to 2. So this is the shortest one, 3 to 2, right? So let's find out. So the maximum wavelength for Balmer series, so I'm using lambda subscript b. Okay, so that will be r into 1 minus n final square, so this square, so 2 square is 4. Okay, and n initial square, so 1 divided by square of that, right? So that is 9. Okay, let's solve this. This will be 36, 4 9 are 36, 9 minus 4, 5. So 5r by 36, okay, and just take the reciprocal of that since you want lambda b. So lambda b will be 36 by 5r. So 36 by 5r. Now you want to take the ratio of this two longest wavelength. This is the longest wavelength for Lyman series, longest wavelength for Balmer series. Okay, so the ratio lambda L by lambda B is what you are supposed to compute over here. So this will be 4 upon 3r into this will be upon, so just flip it over. So that will be 5r divided by 36. R and R will get cancelled. 4 9s are 36, 3 9s are 27. So 5 divided by 27, and that is option D. Okay, so option D, 5 divided by 27 or 5 over 27 is the correct choice over here. Over to the next question. Question number 3 over here, again from the same paper. So in this question, two children are sitting on a seesaw as shown. Okay, yes, they look like this. The one with mass 10 kg is sitting at one end, where so the question is, where should the other with the mass 20 kg sit from the center? So they are asking you for this distance. So where should the other with the mass 20 kg sit from the center so that the seesaw is in equilibrium? Okay, so the equilibrium that is under consideration over here is the rotational one. Okay, translationally the forces are already balanced. Okay, mg is balanced by the contact forces. Okay, so the rotational equilibrium is to be considered over here. Okay, you need to balance the torque on both the sides. Okay, so if you see, this is producing an anti-clockwise torque, this mg, okay, and this one is producing a clockwise one. Okay, so these two torques you need to balance for the seesaw to be in equilibrium. Okay, so basically you can write torque 1 is equal to torque 2, or you can easily use the law of moments. If you know, it simply says m1 x1 is equal to m2 x2. It is basically a condensation of this. So if you write torque 1, if you see, it is m1 g, okay, mass 1 g into the distance. So this distance will be nothing but this is at one end. Okay, so one end, half the distance of 5, that is 2.5. Okay, so this distance from the center is 2.5. Okay, this is in the center. Okay, so this distance is 2.5. Okay, so we are finding torque about this axis. Okay, about this axis. Okay, now torque 2 will be simply m2 g into this distance x that we need to find. It is at a distance x from the center. Okay, so if you see, this and this will get cancelled. So m1 x1 is equal to m2 x2. It simply boils down to this, right? So m1 is 10 kg. The distance from the center is 2.5. Okay, yes, and m2. So if you are asking the question, why didn't we consider the sine theta factor, then you can easily see that the r and f are perpendicular to each other. Okay, r is measured along this direction, f is this, so they are perpendicular. So sine theta is basically 90. Okay, sine 91. Okay, now coming back, so m1 is 10, the distance is 2.5, m2 is 20, and the distance is x. Okay, this is the distance x where the two torques are balanced. Okay, where there is equilibrium. Okay, so the answer will be, x will be over here. If you see, 25 divided by 20, that is like 5 by 4. 5 by 4 is 1.25. Okay, so 1.25 meters, which is option B. Okay, so 1.25 meter is the correct choice over here. This is the distance that the child with mass 20 kg should sit so that the seesaw is in equilibrium. Over to the next question. Question number 4 over here, a very simple question. In this question, you are supposed to tell what will be the effect on the quality factor when the resistance of the circuit is doubled. Okay, so if you directly go by the formula, the quality factor is given as omega naught L by R, right? So from here you can easily see your quality factor is inversely proportional to R, R being the resistance of the circuit. Okay, so if you double the resistance, okay, what will happen? The quality factor will become half. Okay, since it's inversely proportional, right? So if you double the resistance, the quality factor will become half. Option B, become half, will be the correct choice over here. Okay, in fact there is a graph about this in your NCERT. They have plotted, I think, quality factor against frequency or omega. Okay, so here they will show that the plot is like this. For R is equal to 100 ohms, okay, and they have plotted one more graph for R is equal to 200 ohms. Okay, so you can see that this plot is slightly lower, which means the Q value for the second plot is less, okay, and in fact in this case it will be Q by 2, okay. So basically if you double the resistance, the quality factor will become half, okay, and I can say this is an NCERT based question, right? So very simple question. Over to the next question. Number 5 over here, it is slightly tricky. I mean tricky not in terms of concept. Here you are supposed to use the simple concept of equilibrium to find the tension in the string 2, T2, okay. But the thing is, the trickier part is here you are given an angle of 15 degrees, which is not a special angle, and here in this case you'll need to compute sine 15 and cos 15. So you'll have to work your head around it, okay. So anyways, the concept over here that we are going to use is equilibrium, okay, to find T2 in the which is tension in the second string, okay. So first of all, we'll split up this tensions into vertical and horizontal components. So this angle will be also 15 degrees alternate angles, right, and this will be 30 degrees alternate angles, okay. So let's split them up. So if you see, the vertical component is adjacent one, right, so the vertical one is also the adjacent one. So basically adjacent to theta is cos theta, okay. So the vertical component will be T1 cos 15 over here, and here it will be T2 cos 30, okay. So adjacent to theta is cos theta, so that's why the cos component, and this to balances the mg, right. This is in vertically upward direction, mg is in downward. So these two components of the tensions are balancing mg, okay. Now the second equation will come from the horizontal component. So horizontal component, if you see, it will be the sine theta component, right, it is opposite to theta. So here we'll have T1 sine 15, and here we'll have T2 sine 30, right, opposite to theta is sine theta, okay. These two components are balanced among itself because there is no horizontal motion, right. So these two components will cancel out each other. So T1 sine 15 is equal to T2 sine 30, okay. So now our first objective is to express this T1 in terms of T2, okay. So you can replace this T1 over here in terms of T2. Finally we'll have an equation of T2 and mg, then we can easily find T2, right. So first objective is to find T1 in terms of T2, okay. So first of all, sine 30 is half, okay, and we'll need to compute sine 15 over here, okay. So that is an interesting job, the trickier part. So how will we compute sine 15? Let us come over here. Sine 15 is basically sine, so you can actually express 15 as 45 minus 30, right, okay. So this is like sine A minus B, right. So sine A minus B is sine A cos B minus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B, okay. So sine A, which is sine of 45, 1 by root 2, cos B, sine A cos B is cos 30 is root 3 by 2 minus cos A cos of 45 is 1 by root 2, and sine B, sine 30 is half, okay. So if you see, it is root 3 minus 1 upon 2 root 2, okay. This is our sine 15. So let us substitute it over here, root 3 minus 1 upon 2 root 2. So we'll express T1 in terms of T2. So T1 is basically T2, and you can cancel this. So it will be root 2 T2 upon root 3 minus 1. Okay, this is T1 in terms of T2. This we can substitute over here so that we have only T2 in the equation. Okay, and that equation simplifies. Okay, so one more thing that we need to do over here is to compute cos 15, right? Before we plug in that value, let's compute cos 15. Okay, cos 15 again will go by the same method. Actually, you have found sine 15, so you can draw the triangle. Okay, this will be opposite side, this will be the hypotenuse, and then find the adjacent side using the Pythagoras theorem. But I think that will be a longer method. We can proceed through the same method now. Okay, so cos 15 is cos 45 minus 30. So cos has a different formula. Cos A minus B is cos A cos B plus sin A sin B. Okay, cos A minus B is cos A cos B minus plus sin A sin B. Okay, it's cos plus sin. Okay, so cos A, so cos of 45 1 by root 2, cos of 30 is root 3 by 2 plus, okay, opposite sign, sin A, sin of 45 1 by root 2, sin of 30 half. So basically only the sign will change. Okay, so if you see, it is root 3 plus 1, okay, just a coincidence, by 2 root 2. Okay, now let's come to the original thing, the original first equation. So it says t1 cos 15, so in place of t1 we can substitute 2t2 upon root 3 minus 1, right? This is t1. Okay, t1 cos 15 is over here, root 3 plus 1 upon 2 root 2. Okay, root 2 can cancel over here, plus now t2 will keep it as it is. We want to find it, cos 30. Cos 30 is simply root 3 by 2. Okay, no issues over there, and that should be equal to mg. Okay, if you see, your answer is in terms of mg only. Okay, so now what can we do? If you see, we can take this t2 by 2 common, right? If you see t2 by 2 over here, here we will have root 3 plus 1 upon root 3 minus 1. We can rationalize this. We'll do that. Plus, I think root 3, right? Okay, so we are taking t2 by 2 common, okay, from both of them, both of the terms. Okay, finally we can rationalize this, so it will be root 3 plus 1 the whole square. So multiplying the numerator and denominator by root 3 plus 1, and in the denominator we'll have a square minus b square. So a square is 3, root 3 square is 3, and 1 square is 1, so that is 2. So root 3 plus 1 the whole square, so that is 3 plus 1, a square plus b square, plus 2ab plus 2 root 3 upon 2. Okay, so here we are getting t2 by 2. Okay, and once you rationalize it, you will get 4, 3 plus 1 is 4, and 2 root 3 upon 2, right? Once you rationalize this, plus root 3. Okay, so you can simplify it further. I'll do it over here. It is getting a mess, I know, or let us do it over here. Okay, we'll get our final answer over here. So finally, if you see, we have t2 by 2, and you can take the LCM now. So that is 2 over here, and if you, yeah, you can multiply that. So 2 root 3, that is 4 root 3. So 4 plus 4 root 3, and if you see in the denominator also, we have 4, 2 to the 4, right? That will obviously cancel, so all these 4's will cancel. So basically you can take 4 common from the numerator, so you'll be left with 1 plus root 3, and you have 4 in the denominator, 2 to the 4, right? So t2 into 1 plus root 3 is equal to mg, or basically t2 is mg by 1 plus root 3. I know it was a long one, but it was a slightly trickier one because you had to compute sin 15 and cos 15 and then solve it, right? You are not used to solving such type of things, but anyways, that is the way how you do it, and this is your answer, option D. Okay, over to the next question. Number 6 over here, in this question we are given the relative permeability and the relative permittivity of a medium as 1 and 2.25 respectively. You are supposed to tell what is the speed of electromagnetic wave in this medium. Okay, so simply the speed is given as, if you want to write the speed of electromagnetic wave, so in terms of your permeability and permittivity, it's simply mu into epsilon. Okay, now you need to understand this, that this mu and epsilon are the permeability and permittivity of the medium. Okay, if you want to write them in terms of relative permeability and permittivity, they are given as mu r times mu o. Okay, and this will be epsilon r times epsilon o. Here mu r and er are the relative permeability and permittivity respectively. Okay, so you can write this mu into E as 1 upon, so mu can be written as mu r into mu o, mu r into mu o, and epsilon can be written as epsilon r times epsilon o. Now the a special relation that you are supposed to know over here, that speed of light is given as mu naught times epsilon naught. Okay, so if you know the values of these two quantities, actually you can multiply them reciprocal and take the square root, so you'll get the answer as the speed of light. Okay, so this is a special relation that you are supposed to know over here. Okay, this is the general form of it: speed in any medium, speed in vacuum, right? So epsilon naught and mu naught. Okay, and here in any medium, so mu and epsilon, this is for specific medium, right? So here we'll separate out the terms accordingly. So we'll separate out this mu naught into epsilon naught. Okay, in the other bracket we'll keep mu r times epsilon r. Okay, these are the relative permittivity and permeability. Now this we directly know to be equal to speed of light, so this is nothing but 3 into 10 to the power 8 meters per second. Okay, and what about this? This will be the square root of mu r is 1 and epsilon r is 2.25. Now 225 is the square of 15. Okay, I know it just like that. Okay, I know some squares by heart, so 225 is the square of 15. Okay, so basically 2.25 will be the square of 1.5. Okay, this way. Okay, so you can basically shift the decimal and you can write it as 10 to the power minus 2. So that is, so if you take the square root of that, this is 15, and 10 to the power minus 2, that will give 10 to the power minus 1. So this is 1.5. Okay, so basically your answer is 3 into 10 to the power 8 divided by 1.5. Okay, square root of that is 1.5. So 1.5 you can write it as 3 by 2. So I'll write it as 3 by 2. So I think there's something going wrong. So 1.5. Okay, I'm having 1.5 over here. Okay, that is 3 by 2. 3 by 2. So I think this and this should cancel, and the answer should be option A. Okay, yes, option A is the correct choice over here. 2 into 10 to the power 8 meters per second. Okay, yes, that's your answer. Over to the next question. Question number 7 over here. Here in this question, you are supposed to compare the time period of a simple pendulum on Earth to that on Moon. Okay, so you are supposed to tell the correct relation among the following. Okay, I'm not making this up. This is a BITSAT question and such a simple one, right? So time period for a simple pendulum is 2 pi under root L by G. Okay, so the factor under consideration over here is acceleration due to gravity. Okay, rest everything is the same. Okay, so if you see, your time period is inversely proportional to square root of G. Okay, time period is inversely proportional to square root of G, which means where the gravity is less, there the time period is more. Okay, where the gravity is less, where the acceleration due to gravity is less, there the time period is more. Okay, you can easily imagine it. On Earth, if you see, the gravity is more as compared to Moon, right? Acceleration due to gravity is more, so it will pull it down faster. Okay, so the time period will be slow, it will be moving faster, so the time period will be low. Okay, less. Whereas on the Moon, if you see, the gravity will be less. Okay, so it will pull it down with a lesser force. Okay, so lesser force, and the oscillations will be bigger, or time period will be bigger. Okay, so where the gravity is less, the time period will be more, which means gravity on Moon is less, which means time period on Moon is more. Okay, so option B, time period of the simple pendulum on Moon is more than that of Earth. Okay, yes, that's your answer. Over to the next question. So question number 8 over here. In this question, we are supposed to find the electric flux through a cylinder which is kept parallel to a uniform electric field. Okay, so the cylinder is like this and the field is like this. Okay, parallel to the axis, and the field is uniform. Okay, basically means that the field is constant. It does not vary with space. Okay, or time. Okay, so the field is constant, uniform. Okay, so if we draw it over here separately, you can easily see that the number of field lines, electric field lines that are entering the cylinder is equal to the number of field lines that are exiting it. Okay, you can easily see that number of field lines that are entering is equal to the number of field lines that are exiting from that cylinder, right? So basically the net flux is 0, right? Because the number of field lines that are entering is equal to number of field lines that are exiting. Okay, if you don't believe me, let's go through formula. Okay, so if you see, first we'll consider this circle. Okay, so if you see here, the area vector will be like this, outward, right, and the electric field is in this direction. So flux is given as E dot delta S, right? So E is the magnitude of the electric field, delta S, okay, delta S is the area will take it as pi r square, right, and cos of 180, that will be -1, right? So cos of 180, I'll directly substitute it as -1, okay. So this is the field due to the first circle. Okay, now let's come to the curved surface area of the cylinder. Okay, this is the curved surface area. So here you can easily see that the vector, the area vector is perpendicular to the area, right, and electric field is like this. So area vector is always perpendicular to the electric field. Okay, on the curved surface, the area vector is perpendicular to the curved surface, right, and electric field is like this. So it's always perpendicular to the electric field no matter what. Okay, so if you see, phi 2 is E dot S, or Es into cos theta, E into the curved surface area into cos 90. The angle between them is 90, between the electric field and the area vector. So cos 90 is 0, so flux over here is 0. So it's 0 for the curved surface. Finally, coming to the circular shape over here. Okay, so if you see over here, the electric field is in this direction, and area vector will be also in the same direction, pointing outwards, right? Area vector is always outward. So E dot S, and into cos 0, the angle between them is 0. So E into area is pi r square, cos 0 is 1. So this is the flux through your third circle. Okay, so if you find the net flux, so flux 1 plus flux 2 plus flux 3, so you can easily see that this and that will get cancelled, because the number of field lines entering is equal to number of field lines exiting, and the flux, the net flux, is 0 over here. Okay, so option D, 0 is the correct choice over here. 9 and 10 over here, these are pretty simple questions, so let's do them together. First, in question 9, we are asked for the dimensional formula for specific heat capacity. Okay, the simple formula over here is Q equals mc delta T. Okay, Q is heat, M is mass, C is the specific heat capacity, and delta T is the temperature difference. Okay, so just apply dimensions. So Q is heat. Heat is like a form of energy. Okay, it's actually a way of transfer of energy. Anyways, so it has the same dimensional formula as your energy. So mass into velocity square, mv square. So yes, here we'll have mass, specific heat capacity, and finally temperature, which is kelvins. Okay, so m and m will get cancelled, L2 T raised to -2, and k to the other side, that will be k to the power -1. These are the dimension or the dimensional formula for specific heat capacity. Option A is the correct choice over here. Okay, it should be, I think, L2 T raised to -2. Okay, I messed up while writing the options. So yes, it is L2 T raised to -2, K raised to -1. Okay, yes. Okay, let's come to this one. Here the derived unit for EMF. Okay, so is it joule second, joule per coulomb, or watt? Okay, it's very simple. EMF, you can write it as, basically voltage, you can write it as work per unit charge, right? Work done in bringing, so you'll know that definition, right? So EMF is work per unit charge. Okay, so work is measured in joule and your charge is measured in coulomb, right? So the unit for EMF, the derived unit, is joule per coulomb, or it is volt, but it, in the derived form, it is like joule per coulomb. Okay, further you can simplify this, but anyways, in the options we have joule per coulomb. Okay, so joule per coulomb is the correct choice over here. Over to the next question. Question 11 over here. In this question, we have a mass of 0.5 kg, which is making revolutions, 100 revolutions in 50 seconds. It is tied to a string of length 0.5, okay, 0.5 meters. You are supposed to tell what is the linear and the angular velocity. It's quite simple. You can make out the linear, the angular velocity from here, right? And linear velocity you can find using V equals R omega. Okay, so first of all, let us find the angular velocity, which is omega. So first of all, you can see that it is 100 revolutions in 50 seconds. Okay, or you can say just divide by 50, or you'll get 2 revolutions per second. Right, so it is making 2 revolutions per second. So what is the angle covered in each second? So if you see, 2 revolutions mean 2 into 2 pi, right? In one revolution the angle is 2 pi, right? 360 degrees or 2 pi. Okay, so the total angle in radians is 4 pi. So it is covering 4 pi in 1 second. That is the angular speed, right? 4 pi radians. Okay, so if you see, it's 4 pi. What is angular speed? It is the displacement, angular displacement by time taken. So it's 4 pi in 1 second. So it's basically 4 pi radians per second. Okay, so angular speed is this. Okay, and I think C is the correct choice. But let us find the linear speed. It will be omega times r. So omega is 4 pi, right, and times r is basically, if you see, we are revolving it with a length of the string is 0.5 meters, right? So this is the length and this is the linear velocity. Linear velocity is omega times r being the radius, or here it is the length of the string. Okay, so it is 0.5. 0.5 is like 1 by 2, so that is 2 pi. Okay, so 2 pi meters per second, and this is radians per second. Okay, so angular speed, okay, first we have to find linear. So linear is 2 pi and angular is 4 pi. So option C, right? Linear is 2 pi, angular is 4 pi. That's our answer. Over to the next question. Question 12 over here, a question based on escape velocity. Escape velocity is one of the favorite topics of BITSAT. So here we go. We have a planet with mass 2 times that of Earth, and its radius is also 2 times the radius of the Earth. You are supposed to find the escape velocity from this planet in terms of the escape velocity of Earth. Okay, here V stands for escape velocity of Earth. Okay, the formula for escape velocity is under root 2gr, but better than that, remember escape velocity as under root 2gm by r. Okay, 2gm by r. Remember it in terms of capital G, not small g. Okay, because that is very subjective. This is more useful. Okay, so remember it this way, that the formula for escape velocity is under root 2gm by r in terms of capital G. Okay, so the escape velocity from this planet will be 2g. Okay, G is constant, mass is the mass of the planet. Okay, we can say that it is 2 times mass of Earth, so 2 times mass of Earth. Okay, so if you see, the factors are cancelling out each other, and radius also 2 times radius of Earth, these 2 factors will cancel. So basically you will have 2gme by re, which is nothing but, this is for planet Earth, right? It's simply the escape velocity of Earth. This the escape velocity of Earth is simply given as, so m and g, you'll have to replace it by mass of Earth and radius of Earth, which is same as this, right? So basically the escape velocity from the planet is same as the escape velocity from Earth. Okay, so D, which is equal to V, is the correct choice over here. Okay, the 2 factors are cancelling out each other, as you can see. So over to the next question. So question 13 over here, in this question we are supposed to find R equivalent. So first of all, you can note that this is 1 unit, right, and it is repeated 4 times. Okay, so basically I'll find the resistance of this 1 unit and I'll just multiply it by 4, right? These 4 units are in series combination, so R plus R plus R plus R, so it's simply 4R. Okay, so I'll find the resistance of this, that will be R times 4. Okay, so what is the resistance of this? First of all, you can see 10 and 10 in series, that is 20 and 20, and in parallel we have 20 plus 20, which is 40. Okay, so here we have 20 and 40 in parallel, that will give, suppose you have R and 2R in parallel, the shortcut is 2R by 3. Okay, R big by 3. So if you have R and 2R, okay, 20, 40, one is the double of other. So the bigger one divided by 3 is your answer. Okay, that is the shortcut. If you want to verify that, R equivalent over here is product upon sum, right? So 20 into 40 divided by 20 plus 40, that is 60. This and this will cancel for 3. Okay, so that is 40 by 3, as I told you. Okay, but this is not your answer. Okay, this is just for 1 unit, right? You have to multiply. This is R dash, I'll say. Okay, so R equivalent is 4 times. This is just for 1 unit. Okay, so 4 times of 40 by 3, that will be I think this is 4 4s are 16, 160 by 3, and 50s are 150, right? 150 and 53, I can say 50, 53, no. So 3 1s are 3 5s are 15, 15 and how much carry? Yeah, 3. So it should be 53.1. So that is 333. Okay, 53 with a remainder of 1. So that is 53.333. I think this option is incorrect. It should be 53.333. Okay, so 53.333, that is the correct choice, or you can write it as 160 by 3. I don't know about the options, but yeah, whatever option suits over here, 53.33 or 60 by 3, whatever was given. Okay, so that will be the correct choice over here. Over to the next question. So question 14 over here, this is a question based on constrained motion. So very simple question. Here we are given M1 and M2 on an inclined plane. All the surfaces are smooth. There is no friction over here. M1 is given as M. The mass of M1 is M. M2 is 0.5 M. So half of M. Okay, you are supposed to tell the acceleration of the two blocks. Okay, so of course this is constrained motion, so both of them will have the same acceleration. Okay, and acceleration can be easily found out using F net by M total, right? F net by M total, or you can apply the equations of motion, right? F net equals ma for this block, then eliminate tension. That is a long process, right? Here we directly know tension is internal, it will cancel. You just have to look at the net forces that are there. Okay, first is this m1g sine 30. Okay, and next is this one, which is m2g sine 60. They are opposite, you can see. Okay, so it will be this minus this. Net force will be this minus this, or this minus this, whatever. Okay, so net force is we'll take this minus this. Okay, so m1g sine 30, afterwards we'll substitute, and minus m2g sine 60, right, divided by m1 plus m2. So m1 plus m2, 1, this is like 1m, 1 plus 0.5, that is 1.5. Okay, so now time to substitute. M1 is m, g is g. Okay, sine 30 half. Here we have m2 is 0.5 m, right? G is g, sine 60 is root 3 by 2. Okay, and in the denominator we have 1.5 m. Okay, now what can we do? We can take mg by 2 common, mg by 2, mg by 2. So mg by 2, here 1 will be left. Here mg by 2 is common, so root 3 into 0.5. 0.5 we can treat it as 1 by 2, right? 0.5 is same as 1 by 2, and that divided by 1.5 m. M and m will get cancelled. So if you see, it is g by 2 root 1 minus root 3 by 2, or I can take the LCM and divide by 1.5. 1.5 can be written as 3 by 2, right? 1.5 is 1.5, 3 by 2. So okay, it can cancel with one of these 2's, and here we'll have 5 g by 10. G, if we take it as 10, 10 divided by 2, 5 divided by this 3. Okay, this 3, and we have 2 root 3, right? 2 root 3. Now when you solve this, the answer that you will get 5 by 3 is it's 1 with a remainder of 2, so 1.67. okay, and here also you'll get something. So finally when you solve, some calculation is left. I'll leave it up to you. So the answer that you will get over here is option A. Okay, 0.447 meters per second square. That's your answer. Over to the next question. Question 15 and 16 over here, these two are pretty straightforward questions, so let's go through them. In question 15, we are told to calculate the threshold frequency. The work function of the metal is given. Okay, it's pretty straightforward. So you are just supposed to use work function equals h times nu naught. Okay, work function of a metal in terms of your threshold frequency is h nu naught, where nu naught is the threshold frequency. Okay, so the threshold frequency is phi by h. Okay, the only catch over here is that phi is given in electron volts. Okay, you'll have to convert it to joules. Okay, so for that you'll have to multiply 1.6 into 10 to the power minus 90, and h value you should know, 6.6 into 10 to the power minus 34. Okay, so 34 and that is 5, and if we first will convert this 0.16 divided by 6.6, okay, and we have this is 5, 25, and that will take us, yeah, that is 15. Okay, so this is 10 to the power 15. What I'll do, I'll convert this to 16. 16 into 10 to the power minus 2, so I'll subtract those power. So I'm just shifting the decimal to the right, and this will be 10 to the power 13 divided by 6.6, or I can just treat this as 6. Okay, I'm approximating. So if you see, the powers of 10 are changing over here. Okay, 2.4 is the same. So basically, if you say it's 10 to the power 13, okay, that will be your answer. If you want to calculate 16 by 6, okay, it's 2 with a remainder of 4, 2 with a remainder of 4, 2 by 3, 6 by 7, okay, 6, 7, I mean. So 2.67. This is because we took a 6 in place of 6.6, okay. So that is a smaller value in the denominator, so answer is slightly bigger, okay. So for 6.6 it will be 2.4. Okay, anyways, the discrepancy was over here in the powers of 10. You could have directly make it up. Okay, let's come to this one. This one is also simple. You are asked for gamma or Cp by Cv for a monoatomic gas. Very, very simple. Some of you might directly know it by heart. Okay, the formula for gamma, you can write it in terms of degree of freedom. Okay, is 1 plus 1 plus 2 by f. Okay, 1 plus 2 by f. So 1 plus degrees of freedom for a monoatomic gas are 3 x, y, z axis. Okay, so its f value is 3 for monoatomic gas. So 3 plus 2, 5, 5 by 3. Okay, so option B, 5 by 3 is the correct choice over here. Okay, actually you may know it by heart. Yeah, good for you. That's your answer. Next question. Question 17 and 18 over here. In question 17, we have two masses m1 and m2. m1 is initially moving with a speed v1. m2 is initially at rest. Okay, after collision, they start to move together completely in elastic collision. So perfectly in elastic collision. So here both of them move with velocity v2. v2 is such that it is half of v1 or 0.5 v1. Okay, you are supposed to tell what is the loss in the kinetic energy. Right, in elastic collision there is loss in kinetic energy, right. There is some amount of deformation and some amount of kinetic energy is lost, right, on the way. Okay, so that is what you are supposed to find. So basically the thought process is initial kinetic energy. Okay, k over here is the initial kinetic energy. Okay, so initial kinetic energy, if you see, is half m1 into v1 square, right, half m1 into v1 square. This is the initial kinetic energy. Okay, and m2 is at rest, so does not depend on that. Okay, v2 is basically 0 over here. Okay, or the initial speed of m2 is 0, so no kinetic energy from this side initially. Okay, now after collision what happens, these two start moving together, right. So it's half m1 plus m2. Okay, these two masses move together with a velocity v2. Okay, so v2 square. Okay, this is the final kinetic energy. Okay, so there will be some loss. Okay, first of all, the thought processes will find a relationship between m1 and m2. Okay, so that we can express this kinetic energy in terms of that, then subtract. Okay, what will be the loss? The loss will be initial kinetic energy minus final kinetic energy, right. That will be the loss in the kinetic energy, right. So first of all, let us find the relationship between m1 and m2. For that, we'll use momentum conservation. In any type of collision, the momentum is always conserved. Okay, so initial momentum m1 v1, right, is equal to final momentum m1 plus m2 into v2. Here we are given a relationship between v1 and v2. V2 is v2 is 0.5 times of v1, so 0.5 into v1. So v1 and v1 will get cancelled. And here 0.5 you can take it to the other side. 0.5 is basically half, right. You can take it over here. So 2m1 is equal to m1 plus m2, or you can solve this. It will be simply m1 is equal to m2, right. Bring it over here. So m1 is equal to m2. The relation that we get is m1 is equal to m2. So instead of this final kinetic energy, here in the expression we have m1 and m2, right? Both of them are equal, so I can just write 2m2. m1 plus m2 is 2m1. I'll write it in terms of m1 only. So it will be 2m1, and v2 we are told that it becomes half of the initial velocity. So v1 by 2 and that squared, okay, half mv square. So this will be half, we have 2m over here, and v1 by 4, okay, and this is squared, right? So I'll separate out some terms. I'll separate out this 2 and 4 so you can see it more clearly. So what will be left with? So half m1 v1 square, okay. So this is, if you see, 2 by 4 is 1, sorry, half, and this is nothing but half m1 v1 square. This is the initial kinetic energy, okay. What will be the loss? So if you see, the final kinetic energy is k by 2, okay. So what is the loss? Okay, initial kinetic energy is k and final kinetic energy is k by 2. So what is the loss? K by 2, okay. So we'll have to take the difference, but here it's k by 2, so k minus k by 2, 1 minus half, half, okay. So yes, k by 2 is the correct choice over here. Over to the last question for the day, and after that I'll tell you some important topics from which questions were being asked for BITSAT this year, okay. So let's move to the next question now. So now I'll be reading the important topics from which questions were being asked for session 1 of BITSAT. So if you wish to note down the topics, please do so and practice a lot of questions from this topic. Okay, so starting from 4th July, the important topics were toppling, momentum conservation, critical angle, dipole moment, modern physics, current growth and decay, rolling down an inclined plane with stone bridge, that too in unbalanced condition. So refraction, lens basically, and then we have torque, which is rotational equilibrium, one of the questions that we did today, force between two current carrying wires, then we have error and dimension, concentric cells, maybe potential, then cross products, so questions from vectors are also asked, then equivalent resistance, impulse, the question on impulse as change in momentum. Okay, then projectile motion and circular motion. Now let's come to 5th of July. Questions were asked from thermodynamics, fluids, SHM and waves, electrostatics, modern physics, EMI, mechanics. Usually you saw more questions from Newton's law of motion, and other topics also you saw. Then specifically the topics that were important over here are equivalent resistance, the ratio of the de Broglie wavelength, maybe of proton and neutron, something like that. Okay. Then efficiency of Carnot engine, escape velocity, yes, we discussed it today. Then mass moving in a cone, okay, you are supposed to find the velocity, so something of angular motion. Then on the formula of density is equal to mass by volume, maybe significant figures, okay, application of significant figures, maybe on the formula of angular acceleration, work energy theorem, and we have waves equation on the formula of torque equals I alpha. Then heat absorbed, maybe you were given a graph, okay, this is a thermodynamics question, you were given a graph and maybe asked for the heat absorbed from that graph, okay, or maybe the work done, okay. So somewhat on that concept. So coming to 6th July, the important chapters over here becomes kinematics, thermodynamics. So thermodynamics, you'll see questions in every shift this year, so it was an important topic this year. Okay, magnetism, it's always important, SHM and waves, electrostatics, modern physics, mechanics. Okay, again Newton's law of motion, work per energy, and the collision side had a greater weightage. Okay, specific topics important, equivalent capacitance, okay, especially in series. Then we have EMF, okay, circular loop, okay. Then we have spring mass system, maybe the time period of a spring mass system, electrostatics, okay, and then we have questions from harmonic oscillator and coefficient of linear expansion, okay, that is thermal expansion, alpha, okay, coefficient of linear expansion, okay, and then again current carrying parallel kept wires, okay, magnetic field due to them, and then yeah, that's the last topic, okay, that's the last analysis that we have. We don't have anything about 7th of July, okay, but anyways, those were the important topics. I hope you noted that down, okay. I may give the PDF of this in the description box of this video, so do check it out. So So that's all from today's video. I hope you really enjoyed it. If you did enjoy it, smash that like button. I'll see you soon in the next video where we'll be discussing the minor sections of the paper which has equal weightage as physics and chemistry, which is logical reasoning and English. Okay, so in the next video we'll be discussing about logical reasoning and English in depth. So see you there and keep enjoying physics.